Greetings to you all. Welcome back to the lecture of research methodology. In this lecture, I'm going to discuss with you about qualitative and quantitative data analysis. By the way, I'm Wilson Yong from the Biotechnology Research Institute, University Malaysia Sabah. Data is a group of raw facts or information collected for research, reference, or analysis. They are individual units of information that has been transformed into an efficient form for easy movement and processing. Data is the plural form of datum, but most often used as a singular mass noun in everyday usage. It describes a single quantity or quality of an object or phenomenon and is applicable in different fields of research, business, and statistics. In the case of data analysis, we define it as the process of inspecting, editing, transforming and modeling data to discover useful information, informing conclusion, and supporting decision making. In statistics, we generally want to study a population, and you can think of a population as a collection of persons, things, or objects under study. To study the population, we select a sample or subset of the larger population and study that sample to gain information about the population. Data are the result of sampling from a population, and we can calculate a statistic from the sample data. Most data can be put into two categories, qualitative or quantitative. Qualitative data is measured with non-numerical scale. It uses categorical response. The color of a ball or the state of origin would be examples of qualitative variables. Quantitative data is measured on numerical scale. It represents a measurable quantity. For example, when we speak of the population of a city, we are talking about the number of people in the city, a measurable attribute of the city. Therefore, population would be a quantitative variable. These two types of data are quite different, yet they make up all the data that will ever be analyzed. Before diving into data analysis, it is important to understand the key differences between qualitative and quantitative data. Quantitative data is a group of quantifiable information that can be used for mathematical computations and statistical analysis, which informs real-life decisions, while qualitative data is a group of data that describes information. Quantitative data is also known as numerical data, while qualitative data is also known as categorical data. This is because quantitative data are measured in the form of numbers or counts. For qualitative data, they are grouped into categories. Quantitative data are of two types, namely discrete data and continuous data. Continuous data is further divided into interval data and ratio data. Qualitative data, on the other hand, is also divided into two types, namely nominal data and ordinal data. However, ordinal data is classified as quantitative in some cases. Quantitative data takes the numeric value with numeric properties. It has a standardized order scale, and it is visualized using scatter plots, dot plots, and etc. Qualitative data, on the other hand, may take numeric values but without numeric properties, does not have a standardized order scale, and is visualized using a bar chart or pie chart. Quantitative data can be further classified as discrete or continuous. Discrete data is a type of numerical data with countable elements. In other words, they have a one-to-one mapping with natural numbers. A discrete data can either be countably finite or countably infinite. Some general examples of discrete data are the age of an individual, number of students in a class, number of candidates in an election, and etc. A countably finite data can be counted from the beginning to the end, while a countably infinite data cannot be completely counted because it tends to infinity. For example, the bags of rice in a store are countably finite, while the grains of rice in a bag is countably infinite. Also known as attribute data, discrete data cannot be broken down into smaller units. It is typically counted in whole numbers, and there is nothing like half a value. Continuous data is a numerical data type with uncountable elements. They are represented as a set of intervals on a real number line. It takes on numeric values that can be meaningfully broken down into smaller units. As opposed to discrete data, which cannot be measured, continuous data can be placed on a measurement scale such as weight, length, time, and etc. Similar to discrete data, continuous data can also be either finite or infinite. An uncountable finite data set has an end, while an uncountable infinite data set tends to infinity. For example, let us consider the CGPA of students in a class measured on a 5-point scale. A student can score any grade between 0 points and 5 points, including figures like 1.57, 4.5, 2.698, and etc. We classify this an uncountably finite continuous data because it has an upper and lower bound, which is 5 and 0. An example of an uncountably infinite data is the set of real numbers from negative infinity to positive infinity. In this case, the data has neither an upper nor a lower bound. In other words, there is no way that one can count off all elements in the set in such a way that, even though the counting would take forever, you will get to any particular element in a finite amount of time. Continuous data can be further divided into interval data and ratio data. Interval data is defined as type of data which is measured along a scale, in which each point is placed at equal distance from one another. It is an extension of ordinal data, with a standardized scale as opposed to the former. In ordinal scales, the interval between adjacent value is not constant. For example, the difference in finishing time between the first place horse and the second horse need not the same as that between the second and third place horses. An interval scale has a constant interval but lacks a true 0 point. As a result, one can add and subtract values on an interval scale, but one cannot multiply or divide units. For example, the temperature in degrees Celsius is of interval scale. We know that the temperature of 30 degrees Celsius is warmer than 20 degrees Celsius, but 30 degrees Celsius is not 1.5 times warmer than 20 degrees Celsius. Ratio data, on the other hand, is an extension of interval data. It is the ultimate when we talk about data measurement because it tells us about the order, exact distance between units on the scale, and has an absolute zero, meaning there is a point where that measurement, whatever it may be, is not existing. As a result, one can multiply and divide as well as add and subtract using ratio scales. Some examples of ratio measurements are height of a respondent, weight of a durian, time taken to complete a given task, monthly income of a surgeon, monthly expenditure of an average family, test score, monthly amount spent on handphone usage, and others. All these variables can have a value of 0 that represents the absence of the phenomenon being measured. This characteristic of racial data allows for the application of a wide range of inferential and descriptive statistical methods. Qualitative data can take the form of text, photos, videos, and audio. For example, you might be working with interview transcripts, survey responses, field notes, or recordings from natural settings. Most types of qualitative data analysis share the same 5 steps. Prepare and organize your data. This may mean transcribing interviews or typing up field notes. Review and explore your data. Examine the data for patterns or repeated ideas that emerge. Develop a data coding system. Based on your initial ideas, establish a set of codes that you can apply to categorize your data. Assign codes to the data. For example, in qualitative survey analysis, this may mean going through each participant's responses and tagging them with codes in a spreadsheet. As you go through your data, you can create new codes to add to your system if necessary. Identify recurring themes. Link codes together into cohesive, overarching themes. There are several specific approaches to analyzing qualitative data. Although these methods share similar processes, they emphasize different concepts. Content analysis is a research method used to identify patterns in recorded communication. To conduct content analysis, you systematically collect data from a set of texts, which can be written, oral, or visual. You categorize or code words, themes, and concepts within the text and then analyze the results. Content analysis can be used to make qualitative inferences by analyzing the meaning and semantic relationship of words and concepts. Because content analysis can be applied to a broad range of texts, it is used in a variety of fields, including marketing, media studies, anthropology, cognitive science, psychology, and many social science disciplines. Thematic analysis is a good approach to research where you are trying to find out something about people's views, opinions, knowledge, experiences, or values from a set of qualitative data. For example, interview transcript, social media profiles, or survey responses. In thematic analysis, the researcher closely examines the data to identify common themes, such as topics, ideas, and patterns of meaning that come up repeatedly. The analysis allows you a lot of flexibility in interpreting the data and allows you to approach large datasets more easily by sorting them into broad themes. The process was originally developed for psychological research. However, thematic analysis is a flexible method that can be adapted to many different kinds of research. Textual analysis is a broad term for various research methods used to describe, interpret, and understand text. All kinds of information can be gleaned from a text, from its literal meaning to the subtext, symbolism, assumptions, and values it reveals. The methods used to conduct textual analysis depend on the field and the aims of the research. It often aims to connect the text to a broader social, political, cultural, or artistic context. In the fields of cultural studies and media studies, researchers take media and cultural objects, for example, music, videos, social media content, billboard advertising, and treat them as text to be analyzed. Researchers seek to connect elements of their text with issues in contemporary politics and culture. Discourse analysis is a research method for studying written or spoken language in relation to its social context. It aims to understand how language is used in real-life situations. Discourse analysis is a common qualitative research method in many humanities and social science disciplines, including linguistics, sociology, anthropology, psychology, and cultural studies. Conducting discourse analysis means examining how language functions and how meaning is created in different social contexts. It can be applied to any instance of written or oral language, as well as non-verbal aspects of communication such as tone and gestures. By analyzing these types of discourse, researchers aim to gain an understanding of social groups and how they communicate. In quantitative data analysis, once data is collected and processed, you can use descriptive or inferential statistics to answer your research questions. Descriptive statistics summarize and organize characteristics of a dataset. A dataset is a collection of responses or observations from a sample or entire population. Descriptive statistics will give you a summary of your data and describe characteristics of the responses, such as the average of one variable, for example age, or the relation between two variables, for example age and creativity. You can also use graphs, scatter plots, and frequency tables to visualize your data and check for any trends or outliers. While descriptive statistics summarize the characteristics of a dataset, inferential statistics help you come to conclusions and make predictions or generalizations based on your data. When you have collected data from a sample, you can use inferential statistics to understand the larger population from which the sample is taken. For example, you randomly select a sample of graduate students in your state and collect data on their CGPA and other characteristics. You can test your hypothesis or use your sample data to estimate the population parameter and draw conclusions about population. For example, the relationship between CGPA and graduate employability. There are three main types of descriptive statistics. The distribution concerns the frequency of each value. The central tendency concerns the averages of the values, and the variability or dispersion concerns how spread out the values are. For example, you want to study the popularity of different leisure activities by gender. You distribute a survey and ask participants how many times they did each of the leisure activity. For example, go to a library, watch a movie at a theater, or visit a national park in the past year. Your dataset is the collection of responses to the survey. Now you can use descriptive statistics to find out the overall frequency of each activity or the distribution, the averages of each activity or the central tendency, and the spread of responses for each activity or the variability. A dataset of this survey is made up of a distribution of values or scores. In tables or graph, you can summarize the frequency of every possible value of a variable in numbers or percentages. For the variable of gender in the first table, you list all possible answers on the left-hand column. You count the number or percentage of responses for each answer and display it on the right-hand column. From this table, you can see that more women than men took part in this study. In a group frequency distribution, you can group numerical response values and add up the number of responses for each group. You can also convert each of these numbers to percentages, as shown in the second table. From this table, you can see that most people visited the library between 9 and 12 times, or 5 and 16 times in the past year. Measures of central tendency estimate the central or average of a dataset. The mean, median, and mode are three ways of finding the average. Here we will demonstrate how to calculate the mean, median, and mode using the first 6 responses of the same survey on the number of library visits. The mean is the most commonly used method for finding the average. To find the mean, simply add up all response values and divide the sum by the total number of responses. The total number of responses or observations is called n. The median is the value that's exactly in the middle of a dataset. To find the median, order each response value from the smallest to the biggest. Then, the median is the number in the middle. If there are two numbers in the middle, find their mean. The mode is simply the most popular or most frequent response value. A dataset can have no mode, one mode, or more than one mode. To find the mode, order your dataset from lowest to highest and find the response that occurs most frequently. Measures of variability give you a sense of how spread out the response values are. The range, standard deviation, and variance each reflect different aspects of spread. The range gives you an idea of how far apart the most extreme response scores are. To find the range, simply subtract the lowest value from the highest value. The standard deviation is the average amount of variability in your dataset. It tells you, on average, how far each score lies from the mean. The larger the standard deviation, the more variable the dataset is. To calculate standard deviation, find the square of the distance of each data point to the mean. Sum the values and divide the sum of the square deviations by n-1. Then, find the square root of the number you found. From learning that standard deviation equal to 9.18 in this study, you can say that on average, each score deviates from the mean by 9.18 points. The variance is the average of squared deviations from the mean. Variance reflects the degree of spread in the dataset. The more spread the data, the larger the variance is in relation to the mean. To find the variance, simply square the standard deviation. Most of the time, you can only acquire data from samples because it is too difficult or expensive to collect data from the whole population that you are interested in. While descriptive statistics can only summarize a sample's characteristics, inferential statistics use your sample to make reasonable guesses about the larger population. With inferential statistics, it is important to use random and unbiased sampling methods. If your sample is not representative of your population, then you cannot make valid statistical inferences. Since the size of the sample is always smaller than the size of the population, some of the population is not captured by sample data. This creates sampling error, which is the difference between the true population values and the measured sample values. The characteristics of sample and populations are described by numbers called statistics and parameters. A statistic is a measure that describes the sample, for example, sample mean, while a parameter is a measure that describes the whole population, such as population mean. Sampling error is the difference between a parameter and a corresponding statistic. Since in most cases you don't know the real population parameter, you can use inferential statistics to estimate these parameters in a way that takes sampling error into account. Sampling error arises anytime you use a sample, even if your sample is random and unbiased. For this reason, there is always some uncertainty in inferential statistics. However, using probability sampling methods reduces this uncertainty. There are two important types of estimates you can make about the population: point estimates and interval estimates. A point estimate is a single value estimate of a parameter. For instance, a sample mean is a point estimate of a population mean. An interval estimate gives you a range of values where the parameter is expected to lie. A confidence interval is the most common type of interval estimate. Both types of estimates are important for gathering a clear idea of where a parameter is likely to lie. While a point estimate gives you a precise value for the parameter you are interested in, a confidence interval tells you the uncertainty of the point estimate. They are best used in combination with each other. Each confidence interval is associated with a confidence level. A confidence level tells you the probability in percentage of the interval containing the parameter estimate if you repeat the study again. A 95% confidence interval means that if you repeat your study with a new sample in exactly the same way 100 times, you can expect your estimate to lie within the specified range of values 95 times. Although you can say that your estimate will lie within the interval a certain percentage of the time, you cannot say for sure that the actual population parameter will. That's because you cannot know the true value of the population parameter without collecting data from the full population. However, with random sampling and a suitable sample size, you can reasonably expect your confidence interval to contain the parameter a certain percentage of the time. For example, you want to know the average number of paid vacation days that employees at an international company receive. After collecting survey responses from a random sample, you calculate a point estimate and a confidence interval. Let's say your point estimate of the population mean paid vacation days is the sample mean of 19 paid vacation days. With random sampling, a 95% confidence interval of 16 and 22 tells you that there is a 95% probability that the average number of vacation days of employees in the company is between 16 and 22. With that, I would like to end this presentation. Thank you very much for joining me in this lecture. Thank you.